Question 6. We'll insert a calculator page, and what we'll do is we'll define the function p of x as it's given to us. So p open brackets x close brackets. Well, actually we're going to have to use two letters here. Let's call it p of a because we don't yet know the value for a. I'm going to make it defined as equal to. I'm going to press the template button and we're going to choose the piecewise function. Now for this particular one we've got three pieces to this function, but I'm only going to use two, so I can jump straight in with this template here and just type in a times x, and the condition here is naught is less than or equal to x. So control equals gives me less than or equal to x, then control equals gives me strictly less than 1, and then I do a times 2 take away x, and again the limitation here is 1. Strictly less than or equal to x, less than or equal to 2. And we'll press enter. Now it doesn't know the value for a, but we're going to go and work that out. Now the constant value of a will come from when the sum of this probability is equal to 1. So what I should be able to do is press nope, I didn't want to do that. I'm going to press the template key, and I want to do the definite integral over the whole values of this function, which seems to go from 0 to 2. And I'm going to press the var key to pull up my function p, and do x comma a, and I'm going to move to make it dx, and I want to make this all equal to 1. That's effectively the equation I'm going to solve. Now when I press enter, it will give me an error because it doesn't know the value for a, but now when I do menu, algebra, and numerical solve that expression for a, it tells us that a must equal 1, which is rather nice. So I'll do a is defined as equal to, control template, the value of 1, and my function is now well defined for the rest of the question. So what I can do is I can just double check if this function really does satisfy what I wanted it to do. Notice the a now is in bold because it knows the particular value for a which it takes, and we get a value for 1. Now the expectation will come from inserting an x in front of my distribution, and I get an expectation of 1, which is quite nice. And the variance will come from, well, not straight away just doing x squared. We'll use this value in a minute. So it'll be that value take away that value squared, which is slightly different. And then if I want to see that as a fraction, I can do menu, number, approximate it to a fraction. I get some monster there, which doesn't quite look like what I've done. There may be lots of rounding errors here. So what I'm going to do is I'm just going to re-execute that command, but reduce the accuracy. Instead of 10 to the minus 14, make it 10 to the minus 10, and I get 1/6. So my variance here is 1/6, and my expectation is 1. And the probability at which it wants to go from 3/4 to 3/2, let's just go back up to my original statement there, and instead of the lower bound being 0, I'll type in 3/4, 3 divided by 4, and instead of the upper bound being 2, I'll do 3 divided by 2. The value for a is still well defined. I have that decimal there. Let's see if it's a recognizable fraction. I'll do number, approximate to fraction. It's looking a bit awkward. We might have a decimal issue there again, so I'll just change the accuracy. No, it's still the same answer as before. So you might well be acceptable to leave it, well, to 3 significant figures as 0.594. And we're done.